Imagine a place where towering volcanoes pierce the clouds, whispering forests hide ancient secrets, and wild ocean waves crash against dramatic cliffs. This is the Pacific Northwest, a land of breathtaking beauty, but also of deep geological mystery. However, beneath this serene beauty lies a dangerous truth. The Pacific Northwest is one of the most geologically active places on the planet. Mount St. Helens, still scarred from its explosive eruption in 1980, has long been a source of fascination and fear. And as if the volcano's presence wasn't enough, something else is lurking in the depths. Scientists have discovered a mysterious leak on the ocean floor just off the coast of the volcano. Could this be a sign of something far more sinister brewing beneath the surface? What dangers could this underwater enigma hold for the Pacific Northwest, and potentially the entire planet? Mount St. Helens is a volcano known for its fiery temper, marked by explosive outbursts and dramatic eruptions. Scientists have closely monitored this volatile peak for decades, fully aware of its precarious location along the Cascadia subduction zone. This zone is a hotspot of geological activity, where two massive forces of nature, the Juan de Fuca Plate and the North American Plate, are locked in a slow-motion collision. The Juan de Fuca Plate is being forced downwards, grinding beneath the North American Plate, generating immense pressure. This pressure creates an active geological environment, a breeding ground for earthquakes and volcanic eruptions. To stay on top of this activity, scientists have equipped Mount St. Helens and its neighboring volcanoes with advanced monitoring equipment. But while the scientists were focused on the mountains, something unexpected was happening in the depths of the Pacific Ocean just offshore. During a routine seafloor mapping expedition, scientists stumbled upon a bizarre discovery: a mysterious leak spewing strange fluids from the ocean floor right next to the volcano. This unexpected find has raised alarms and left everyone wondering what this underwater anomaly could mean for the future of the Pacific Northwest. How did scientists even find this leak? The discovery began with unusual readings from thermal imaging scans of the ocean floor, where scientists noticed a strange patch of seabed releasing warm fluid at an alarming rate. Initially, they dismissed it as a common hydrothermal vent, which is frequently found near tectonic boundaries. However, it wasn't just another hydrothermal vent. Upon further investigation, researchers discovered that the fluid wasn't merely hot water from the Earth's mantle. It was a mixture of methane, carbon dioxide, and other gases typically associated with volcanic activity. Even more concerning, the fluid contained chemical compounds suggesting a direct connection to the magma reservoirs beneath Mount St. Helens. This discovery was not just an odd find, it was a flashing red warning signal for geologists. Such a leak usually acts as a pressure release valve for magma chambers, temporarily easing stress. But there's a catch: if the pressure continues to build beyond what the system can handle, it could lead to catastrophic events such as seismic activity or even volcanic eruptions. Adding to the danger, this leak sits dangerously close to the Cascadia subduction zone, an area infamous for megathrust earthquakes. These quakes, which can reach magnitudes of 9 or higher, could trigger widespread devastation. The presence of this volatile leak near a major fault line only amplifies seismic risks, making an already fragile situation even more hazardous. The composition of the fluid leaking from the ocean floor adds another layer of concern. Among other substances, it is releasing methane and carbon dioxide, both potent greenhouse gases. While the current amounts being released are small compared to global emissions, this leak is akin to finding a crack in a dam. What happens if it worsens? Methane, in particular, is a powerful contributor to global warming, trapping heat at levels far beyond carbon dioxide. A significant methane release from this underwater source could potentially destabilize Earth's delicate climate system. Scientists are now racing to determine whether this leak is an isolated incident or part of a larger, hidden network beneath the ocean floor. To understand the full scope of the situation, researchers must consider the history of methane hydrate destabilization. Methane hydrates are methane trapped in icy cages beneath the seafloor, and they remain stable under specific conditions. However, a small disturbance, such as rising temperatures or changing pressures, can cause these hydrates to collapse, releasing massive amounts of methane. Even more worrying, The leak appears to be connected to a massive reservoir of methane beneath the seafloor. If warming continues, whether due to geothermal activity or climate change, it could trigger a chain reaction that destabilizes more hydrates and sets off a dangerous feedback loop of warming and methane release. With Mount St. Helens already showing signs of restlessness, this underwater leak adds a new level of complexity and danger to an already volatile situation. What are the risks? Could this leak trigger a catastrophic chain reaction, setting off earthquakes, eruptions, and possibly tsunamis? Is the Pacific Northwest sitting on a geological time bomb? The stakes are enormous, both environmentally and geologically. The connection between the ocean floor leak and Mount St. Helens suggests something unsettling. Magma deep within the Earth is moving in ways scientists didn't predict. This movement could trigger volcanic activity not only at Mount St. Helens but across the Cascade Range. Could this be the spark that ignites a chain reaction of eruptions? While the USGS assures the public that there is no immediate cause for panic, the urgency behind the scenes tells a different story. Emergency teams are dusting off evacuation plans, and geologists are glued to seismic monitors, watching for any sign of escalating activity. The biggest concern remains whether this leak is the precursor to a major eruption at Mount St. Helens. The eruption of 1980 devastated 230 square miles of forest, claimed 57 lives, and sent ash clouds around the globe. Today, the region is more populated and packed with infrastructure, making the stakes even higher. But it's not just Mount St. Helens that's keeping experts on edge. The Cascadia subduction zone, known for its earthquake potential, looms nearby. A megathrust quake in this region could mean widespread destruction, with ground shaking for hundreds of miles and tsunamis barreling into coastal towns. What's even more troubling is the possibility that this leak isn't an isolated event. It could be part of a larger, interconnected system between deep-sea processes and seismic instability that we're only beginning to understand. To find answers, scientists are sending in cutting-edge robotics and deep-sea submersibles to investigate further. These tools are mapping the seafloor, collecting samples, and closely monitoring the leak. Early reports are already raising concerns. As the leak shows no signs of slowing down, it's actually growing. Its size and intensity are increasing, pointing to deep instability in the geological structures below. For now, all eyes are on the data, and the sense of urgency grows with every new discovery. The discovery near Mount St. Helens has the potential to change everything we thought we knew about Earth's geological activity. This leak isn't just a curiosity. It's a sign that something much larger might be at play beneath the surface. Could this be the start of a new era of tectonic unrest? As we continue to witness the planet's evolution, with plate tectonics and climate change interacting in unpredictable ways, this event could be the precursor to a series of global shifts. The ripple effect could span across tectonically active regions, suggesting a broader pattern of disturbance. This leak serves as a reminder of how interconnected our planet's systems are. The cascading consequences of even a localized disturbance can affect the entire globe. For instance, an increase in volcanic activity along the Cascade Range could release massive amounts of aerosols into the atmosphere, potentially altering global weather patterns and threatening agricultural stability. Additionally, if methane from this leak enters the atmosphere, it could create a vicious cycle, further destabilizing methane hydrates and accelerating climate change. The domino effect could reshape Earth's future, with extreme weather events and rising sea levels becoming the new normal. At a time when humanity is already struggling with climate challenges, the leak serves as a stark reminder of Earth's power and unpredictability. It forces us to confront larger questions. Are we merely bystanders in a geological drama that's been unfolding for billions of years? Or do we have a role to play in mitigating the impacts? With new technologies at our disposal, can we adapt to a planet that is changing before our very eyes? Or are we at the mercy of forces far beyond our control? The more scientists dig into the mystery of this leak, the more questions arise. As they study the site, they are uncovering new layers of complexity that challenge our understanding of the planet. This discovery isn't just another geological event. It's a wake-up call. The Earth is alive, constantly evolving, and this leak near Mount St. Helens is just one example of how volatile that can be. Could we be facing a natural disaster that no one saw coming? For researchers, this discovery marks the beginning of a race against time to understand what's happening deep beneath the ocean floor and what it could mean for the future. As the investigation continues, several surprising revelations have emerged. This leak is no longer an isolated event. Data from deep-sea monitoring equipment has revealed that the leak is part of a much larger network of fissures extending over several square kilometers. This network forms what scientists are now calling a submarine geothermal system. Not only is it venting gases like methane and carbon dioxide, but it's also releasing superheated water and trace metals from Earth's crust. So, what could the long-term effects of this system be on the ocean's delicate ecosystem? Preliminary studies indicate that ocean temperatures in the area are rising sharply, and the water's chemistry is shifting. Marine life near the leak is behaving strangely. Some species are fleeing, while others are being drawn to the area. This change in behavior suggests the presence of something toxic or other environmental changes at play. Scientists are scrambling to understand what's happening and what it means for the broader marine ecosystem. Perhaps the most surprising discovery comes from the isotopes found in the leaked materials. These isotopes, which are rarely found on the Earth's surface, are believed to originate from deep within the planet's mantle. This is unsettling because it suggests that the leak is tapping into geological layers far deeper than anyone expected. How far down does this system extend, and what might we discover as we continue to explore? This revelation raises even more questions. Could there be unknown geological structures beneath the surface, just waiting to be unleashed? The deeper scientists investigate, both literally and figuratively, the more complex the situation becomes. The interconnectedness of the fissures and the strange isotopic signatures suggest an underlying cause far more complex than typical volcanic activity. Some researchers speculate that the leak could be connected to geological structures that predate the region's current tectonic configurations. Adding to the intrigue are seismic tremors, known as harmonic tremors, often associated with magma movement and volcanic activity. However, the tremor patterns in this area are unlike anything previously recorded. Some experts are hypothesizing that the leak could be part of a much larger geological event still unfolding. Could this be a precursor to an underwater volcanic eruption? While most people associate volcanic eruptions with dramatic, fiery explosions and lava flows, underwater eruptions can be even more destructive. The immense pressure of the ocean can contain the blast, but the sudden release of gases and heat could trigger tsunamis, destroy marine life, and send shockwaves through Earth's crust. If an eruption were to occur near Mount St. Helens, the consequences could be catastrophic. Coastal communities would have little time to react, and the potential for widespread destruction and loss of life would be immense. As scientists continue to explore worst-case scenarios, they are also trying to piece together how this leak fits into the bigger picture of Earth's geological processes. One theory gaining traction is that the leak could be part of a superplume system, a massive column of hot rock rising from deep within the mantle. Superplumes are thought to drive major geological events, such as volcanic hotspots and the splitting of continents. Could this leak be connected to one of the most significant geological events of the century? This theory, while intriguing, also has alarming implications. Superplumes are incredibly powerful and unpredictable, capable of reshaping entire regions over long periods. If Mount St. Helens is sitting on top of one of these superplumes, the future of the region could be far more volatile than we ever imagined. The question remains, are we ready for the changes that may be coming? When the leak near Mount St. Helens was first discovered, no one knew quite what to make of it. What started as a puzzling anomaly is now raising environmental and geological alarms that are impossible to ignore. The release of methane and other greenhouse gases is causing concern not just for the immediate region, but for the entire planet. What's even more alarming is the possibility that this leak could destabilize methane hydrates in the region, turning an already serious issue into something much more complex. As scientists continue their research, the leak's impact on the ocean's chemistry is raising significant concerns. Marine ecosystems, many of which rely on stable conditions, are at risk. Even small shifts in temperature or chemical balance can create catastrophic changes. If the leak disrupts ocean chemistry on a large scale, the consequences could be global. We might soon witness the devastating collapse of local fisheries, a phenomenon that could trigger the extinction of numerous species that rely on these delicate habitats for survival. The intricate web of interconnected ecosystems means that even a seemingly minor disruption could lead to a domino effect, sparking a cascade of environmental consequences that are impossible to ignore. This interconnectedness underscores the urgency of addressing these challenges, as the stakes are higher than ever. In the face of such grave concerns, the discovery of the leak has acted as a catalyst for international collaboration, bringing together geological surveys, research institutions, and environmental organizations from around the globe to study the site comprehensively. Early findings have been nothing short of startling, suggesting that similar leaks may exist undetected in other tectonically active regions, hidden in plain sight due to insufficient monitoring efforts. This global joint initiative is not just illuminating the specifics of this particular leak, but also expanding our broader understanding of the powerful geological processes unfolding beneath our feet, many of which often remain hidden from view. To investigate the leak, researchers are utilizing cutting-edge technologies that are redefining the scope of underwater research. Autonomous underwater vehicles, AUVs, are meticulously mapping the seafloor with unprecedented precision, revealing intricate geological details that were previously inaccessible. Simultaneously, remotely operated vehicles, ROVs, are collecting samples, analyzing gas compositions, and capturing high-resolution imagery that offers unparalleled insights into the site's dynamics. These technological advancements are revolutionizing our understanding of underwater geological phenomena, enabling scientists to gather an extraordinary amount of data. Despite these groundbreaking strides, critical questions still linger. What was the initial trigger for this leak? Is it a harbinger of broader geological instability within the region? Most importantly, what steps can humanity take to mitigate and prevent future leaks of this nature? The answers to these pressing questions are not merely academic. They hold the potential to reshape our understanding of the Earth's complex systems and offer critical guidance for future preparedness. One promising solution being explored involves the implementation of advanced containment technologies. This approach aims to capture the escaping gases to reduce their environmental impact while simultaneously providing valuable data on their chemical composition and behavior. However, the deployment of such solutions is fraught with logistical challenges. Successfully implementing containment measures requires immense resources, detailed planning, and seamless coordination among multiple stakeholders. It is a race against time to mitigate environmental damage, but the knowledge gained from this effort could revolutionize our approach to similar incidents in the future. In parallel, researchers are dedicating significant effort to predicting future geological activity in the region. By analyzing seismic activity, gas emission patterns, and other crucial indicators, they aim to develop predictive models that could forecast when and where additional leaks or eruptions might occur. Such advancements could empower communities with the tools for better preparedness and response, potentially saving lives and protecting vital ecosystems. However, these efforts also highlight the limitations of our current understanding. Despite all our technological advancements, the forces at play beneath the Earth's surface remain enigmatic. The complexity of tectonic movements, subterranean pressures, and their intricate interactions continue to challenge even the most sophisticated scientific models. This stark reality underscores the dynamic and unpredictable nature of our planet. As scientists, policymakers, and organizations work to address the challenges posed by the leak, the incident serves as a powerful reminder of the Earth's ever-changing character. It calls attention to the delicate balance of natural systems and the critical importance of advancing our understanding of these processes. The leak near Mount St. Helens is more than just an isolated event. It's a wake-up call to humanity. It forces us to reconsider our relationship with the planet, highlighting our responsibility to protect its fragile ecosystems and the interconnected web of life that sustains us. This discovery is not merely a scientific anomaly, but a profound reminder of the hidden forces shaping our world. It's a rallying cry for innovation, collaboration, and proactive engagement, urging scientists, policymakers, and citizens to work together to address the environmental challenges that lie ahead. As we look to the future, The path forward is fraught with uncertainties. There will be setbacks, challenges, and moments of fear. Yet, within these challenges lie opportunities for innovation, discovery, and growth. This situation demands a united front, pushing humanity to harness its collective creativity and determination to find solutions. The ongoing investigation into the leak presents us with a choice: to retreat in fear and hope for the best, or to face the unknown with courage and resolve. The way we respond to this challenge will define not only our understanding of this particular incident, but also our broader commitment to safeguarding the environment and securing a sustainable future for generations to come. What lies ahead for the Pacific Northwest? Could Mount St. Helens awaken with renewed ferocity? Might the ocean floor reveal further hidden dangers? And how will these developments affect the delicate balance of life on Earth? The answers are veiled beneath the ocean waves, within the depths of the Earth, and in the hands of those brave enough to explore the unknown. What do you think will happen? Share your thoughts in the comments below, and don't forget to subscribe for more groundbreaking discoveries. Thank you for joining us on this journey of exploration and understanding.